Namaste. Welcome to this channel, Dr.ARM's Chemistry. Last time we have seen the naming of ligands and how to write the formulae or how to show the short form of these ligands. The ligands are monodentate and polydentate. We know that the simple complexes are obtained by using monodentate ligands, while the complexes which are obtained by using polydentate ligands are called chelates. Now we will see how to show the names of these complexes, that is, naming the complex. So there are a set of rules given for the exact IUPAC nomenclature. The first rule is naming cations and anions. Naming cations and anions. A complex may be neutral, but it may have one or two particles, and depending upon that, it is composed of either a neutral single particle or it is composed of a pair of a cation and an ion, and depending upon that we have to write the name of the complex. For example, if we take this complex AgNH3 twice Cl, AgNH3 twice Cl. So this complex is containing two particles. So this is one particle and this is another particle. Means it has two parts. So this is a cation and this is an ion. So we have to show the names of these two complexes separately, two components separately. So this name is given first. Name of this cation should be given first, followed by name of this anion. Then, for example, how to write this? There are two such amine or amino ligands. So it is called diamino, silver. The name of silver is argentate, diamino silver, or it can be called argentate or Now here oxidation state of this is 1. So we are to show here 1. Followed by name of this anion, chloride. And the names should be separated by some space. So the name of this complex species, if it is cation, it should be separated by the name of the anion. So the two words are giving us the name of a complex species. Then if we take another example, now if you see this K3 FeCl6, K3 FeCl6, then you will find this is a cation and this is anion. The name of this cation is to be written as potassium. There is no need to show tripotassium, means there is no need to indicate the number of this K, only potassium is enough. Then name of this anion by leaving some space here. So 6, that is hexacyano. Now this is anion. So name of this iron is ferrate. Oxidation state of this is 3. So this is the name for this complex K3FeCl6, that is potassium hexacyanoferrate. For example, if we have another complex K4, if we say K4 FeCl6, then name of this complex is also called potassium. There are this hexacyanoferrate. 2. The oxidation state is different, so that there is only this difference. Now here it is K4, it is K3. There is no need to indicate the number of metal ion, that is K. So this is first rule. Then second rule. The second rule shows that the inner coordination sphere is enclosed in a square bracket, and so we are showing second, that is showing the name of the complex in which we have to show the inner sphere of coordination. So this is to be shown in a square bracket, but in the formulae, means when we want to show the formulae of this complex, we have to show this. Then the contents or components of the complex are shown continuously. This, if for example, if it is CO and H3, CO, Cl2, NH3, 4, then there is Cl. So the components which are included in a square bracket are to be shown as a single word. Now, how to show this? So first of all, even though the square bracket contains here metal ion, cobalt, the chloride ions, the ammonia molecules, we have to first indicate the name of metal in this complex while we are showing in this complex. But when we are writing the name of this complex, we have to follow the alphabetical order for the ligands. So alphabetically, amine, that is ammonia ligands, are coming first, followed by this Cl, that is chloro ligands. So we have to show this as tetrapole, that is tetraamine. Tetraamine. There are two chloro, dichloro then followed by this cobalt. Then oxidation state of this is 3, followed by some space and name of this ligand, that is chloride. So in this way, this contains, or we can say the ligands and metal ion is shown here as a single word. There should not be any space. There should be no space. Tetraamine is dichlorocobalt is shown continuous without leaving any space. Then oxidation state is shown in the square bracket, followed by some space and the name of the anion, which is shown outside the square bracket, that is chloride. So in this way we can show the contents or components of these inner coordination sphere in this way. The number of ligands, next is third rule, number of ligands. So the number of ligands are shown as, so depending upon the ligands of same type, we have to use the different words, prefix. For example, when there are number of ligands 2, 3, 4, 5, 6, 7, 8, 9 and 10, then we have to show these ligands the prefixes. So prefixes should be used like this for monodentate and for polydentate ligands. So we have to show the prefixes like this. This is di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So in this way we have to show the prefix. When there are two ligands, we have to indicate it as di. When the same number of ligands are 3, we have to show the prefix tri. So in this way, 4 ligands are shown with tetra prefix, 5 ligands are shown with prefix penta. Similarly, 6 ligands hexa, 7 hepta, 8 octa, and 9 nona, and 10 deca. So this is about the monodentate ligands. If the ligands are polydentate, it contains the ligand name itself contains some prefix or some number indicating the points of attachments. So for example, if the polydentate ligands have 2 points of attachments, that is a bidentate ligand, means the number of such bidentate ligands are 2, or the number of ligands, the points of attachments may be 2, 3, 4, but the number of such ligands when are 2, it is represented not by di. The separate prefix is designed for this naming, that is bis. So it is named, prefix is given as bis. For example, it is the ligand is oxo, then it is called bis oxo. Or if it is oxalato, then bis oxalato. Then if it is the ion, that is ethylene diamine, then we can say bis ion, or that is ethylene diamine. So we have to show this prefix before the name of the ligand, and followed by the hyphen and parenthesis, and we have to name that ligands in the parenthesis like this. So if it is ethylene, we have to write here ethylene diamine in parenthesis. Similarly, when the prefix is 3, the number of ligands are 3, we have to write it as tris. Then when the number of ligands, polydated ligands are 4, we have to show it the prefix as tetrakis. Then pentakis. Then hexakis. Then heptakis. Then octakis. Then nonakis. Then decakis. Like this. So we have to use this number system because the ligand name itself contains some numbering, that is di, tri, etc. For example, ethylene diamine, as we can show here or in another example. Say it is say Cl2 NH3 the short form for ethylene diamine is used as EM, so it is 2 and Cl. Then we can derive the name like this. Here the name is derived like this. Here this ethylene diamine E, but before that alphabetically C is coming first, so we have to show that dichloro, then it is bis in parenthesis ethylene diamine, in parenthesis, followed by the name of metal, that is cobalt. We followed by some space and name of this. Cobalt has oxidation state 3, followed by some space and name of this chloride. So name of this complex is dichloro bis ethylene diamine. So we have shown this bis because the number of such EN polydentate, that is bidentate ligands are 2. So we have to use bis. We cannot use double because the name itself contains di. So we have to avoid repeating the use of such number, that is ethylene diamine. So that will be not good or suitable name. So in this way, this nomenclature system is followed here to indicate the name of the monodentate ligands and polydentate ligands. Then next rule, fourth, is ligands are generally written in alphabetical order. So fourth, write the name of names of ligands in alphabetical order. So we have to follow this order, alphabetical order, while naming the ligands. So we have shown number of such examples. For example, we will take a specific example like this. So this is mate. Then we are writing the names like this. Say NH3, or when we are Cl, then CH3, NH2. So here you will find that we have to use the alphabetical order. So alphabetically, this A comes first, that is amine, followed by this bromo, Br, bromo, followed by this chloro, and followed by this methylamine, platinum, oxidation state 2. Since the complex is neutral, there is no change in the name of this platinum. If it would have been anionic, then it should have been converted into platinate, but it is neutral. So the name of metal ion remains unchanged. So we have to follow this nomenclature system. Sometimes, means while writing the names, we are also showing this name like this: platinum, Br, Cl, NH3, like this. Means negative ligands are written first in square bracket, then other ligands, neutral, and cationic ligands are shown at the end. Means this is the order of indicating the ligands. So we can show these ligands in this way in alphabetical order. Now next is the ending of ligands, ending the name of ligands. Fifth, ending the name of ligand. When the ligand is neutral, there is no change in the name of ligand. So for example, amine, it is written as amine. So we have seen that if the ligand is water, it is written as aqua without any change. So in this way, if the ligands are anionic, the name of the ligand ends with O. For example, if you will find here bromo, when the anion is Br, we see it is bromide. Br ligand, Br minus, is indicated as bromide. But this ID is replaced by O in order to give the name of ligand, that is bromo, chloro, iodo, fluoro, hydroxo, etc. So we can see the previous table. In the previous lecture we have shown the large number of data in which monodentate and polydentate ligands are given. Then next rule is about oxidation state. That is oxidation state. While writing the name of a complex, we are showing the names of ligands in alphabetical order and using appropriate nomenclature system, numbering system, in which the number of ligands are also shown, and the total name of the complex shown in square bracket is written as a single word, and that word ends with name of metal, and followed by this name of metal we have to write the oxidation state of the metal. So we have shown here platinum is the name of the metal, oxidation state is shown in this parenthesis. But sometimes the oxidation state may be ambiguous, means we cannot state the oxidation state perfectly because it may have some fractional or there is ambiguity in order to express the oxidation state in a single figure. So in that case we have to show the oxidation state on the complex. Since this complex is neutral, so for example we are having the ambiguity in the complex or oxidation state, then we have to show the total oxidation state as, say, if the resulting oxidation state on the complex, generally when the there are two cation is complex, anion is complex, or the metal ion is existing in different oxidation states, and therefore the resulting oxidation state is difficult to indicate. So in that case we have to show the oxidation state with the oxidation or charge on the complex. Charge on the complex. So if there is, say, 2 plus charge on this complex or any other complex, so we have to, instead of showing this, we have to show plus 2 oxidation state charge. This is not oxidation state, this is charge on the complex. Because oxidation state are ambiguous, then it is better to indicate charge on the complex in parentheses. So this is according to the Ewing-Bassett system. Ewing-Bassett system. So in case of ambiguity about the oxidation states, we have to indicate the charge on complex in order to avoid confusion. Then we have to show that the anions, name of the anions are ending with ATE. Anions are indicating with ATE. For example, Fe(Cl)6 3 minus. So hexa, cyanoferrate, ferrate 3, hexacyanoferrate. So here RAT is coming when the complex is anionic. So the name of metal name ends with ATE suffix ATE. For example, ferrate, cobaltate, tungstate, stannate, or platinate, etc. Then the prefix designating the isomer, is shown at the beginning of the names. Seventh rule. Prefix for designating isomer. For example, the complex may have cis isomer, trans isomer. Then we have to indicate that using the prefix cis before writing the name of the complex. For example, if we show the complex platinum Cl2 NH3 twice, Cl2 NH3 twice, then we can show this. If the complex is cis, then this hyphen followed by this alphabetical order of our naming, that is amine groups. So the cis, then this diamine, that is cis diamine, dichloro, then this is a neutral complex. The charge on this complex is neutral. So we show that it is platinum. Oxidation state 2. So it becomes cis diamine dichloroplatinum. Then if we have the trans isomer, another example, if we take the CO Cl2 NH3 twice, then we can show this trans isomer in which the Cl as well as this NH3 are lying at trans positions, mean at 180 degrees in octahedral complex. Then we have to show the prefix trans. Then in this after this we have to show, that is diamine dichlorocobalt, cobalt 3 or 2, whatever it may be. So it is 3 here. And it is positively charged. So the name of metal ion does not change. Or it can be cis depending upon the positions. So this is the 7th rule. Now, next rule is when the complex contains metal ions more than one, and these metal ions are interlinked with each other by means of some bridging ligands, then such bridging ligands are shown by using a prefix mu, that is it indicating bridging ligands. So they are shown with prefix mu. Means for each ligand which is acting as a bridge, we have to show mu. So in this way, if we take the example of this CO, this is NH3, NH3, this is NH3, NH3. Then if it is OH and here it is NH2, then NH3, NH3, NH3 and NH3. So there is charge plus 4 on this complex. So here you will find that these OH and NH2 are bridging ligands, whereas Other ligands are called terminal ligands, means there is no bridging. So such name of the ligand is shown in alphabetical order. So first of all, this is hydroxo and this is amino, or it is called amido. NH2, it is NH2, not NH3. So it is amido. So we are, according to alphabetical order, this amido comes first before hydroxo. So we have to show this as mu, amido. Then again mu, this hydroxo. Hydroxo. Then followed by other ligands. That is, so there are two such species, means two metal ions. So we have to indicate that this, that the four ligands in each metal ion, that is tetraamine, cobalt, tetraamine, cobalt, and we have to indicate the oxidation state, that is +4, or we have to indicate the charge, that is +4. So this is Ewing system, Ewing-Bassett system. So we have shown here charge on this complex. The oxidation state of each metal is 3. And so these 3 and these 3 means we cannot say 3 plus 3, 6 oxidation state. So in that case it is better to indicate charge on the complex. So we have shown here charge. It is not the oxidation state. Then the next rule is ninth, thus naming the metal ions. Naming metal ions. So the complex may be neutral, cationic or anionic. Then name of these metal ions are derived by using sometimes the source of name of the metal. Source of name of the metal. The name, the complex may be anionic. Then we have to use when complex is anionic, the name of metal is derived from the source of metal name. But if the metal ion is neutral or cationic, there is no need to use such source of the name of metal. So we have to indicate the name of metal as it is. For example, cobalt, platinum, iron, etc. There is no change in the name of metal. So in that case, we are using this rule. But when the metal ion, the complex is anionic, we have to search for name of the source of metal. For example, if the symbol is Fe, we can show it as it is commonly named as iron. But the source of this iron is ferrum, and from which the name of such metal is derived as ferrite. Here. If the name is AG and if the complex is anion, then we have to derive this name as argentate. Argent. Similarly, if we are having cobalt, then we have to use it as a cobaltate. Cobaltate. Then if we are having the Pb, that is lead, it is lead, but its source name is plumbate. Plum. The name is derived as plumbate. Plumbate. Then if the metal is Sn, tin, it is called a stannate. The name is derived as stannate. Stannate. If the metal is gold, the name is derived as aurate. A-U-R-A-T-E. So in this way, these names are derived from their source. This is cobalt, commonly used as it is. So these are shown in this nomenclature system using the source of metal name. Then last is so these are about the rules. So this is okay. But in addition to this, we will see some part which is already seen in previous lectures. That when we are writing the name of or formula of the complex, sometimes the formula of the complex is written as, say, Fe Cn 6 3 minus. So this is a complex. But if the metal is bonded like this, MnO4 minus, then we have seen here that the contents or metal ion and ligand is enclosed in square bracket, but there is no need to enclose this species in square bracket because there is no need to show such species, and when the ligands are generally neutral like this, Ni CO4 tetracarbonyl nickel, this is named as tetracarbonyl nickel. Oxidation state is shown here. Here nickel is in zero oxidation state, cobalt is also neutral. So resulting charge on the complex is also neutral. So in this way we are using the different nomenclature system. So this is enough today. So we'll stop our discussion here and we'll see the next topic or next point in the next lecture. So till then, see you. Goodbye. Please subscribe to this channel. Please press the like button if you like these contents and press bell icon. You can also suggest about the contents which you like to discuss, so that may be considered in lectures in future. So